Hi, my name's Tim, and I'm going to be taking you through target 3 from test number 12505. So we want the greatest positive integer n, for which the nearest whole percent of root n over n is 10%. All right, so here's the thing. If the nearest percent is going to be 10%, that means it's got to be closer to 10 than it is to 9. It's got to be closer to 10 than it is to 11. All right, so we've got an interval here that says that 9.5% is that cutoff point. All right, so 9.5% is going to have to be less than root n over n, and that is going to have to be less than 10.5%. Now, at this point, the problem pretty much solves itself, right? We just have to go through the motions on this one. We are looking for the greatest positive integer, right? So we're looking for an integer, and it's going to be the greatest one that works within these constraints. Okay, so first thing I want to do is simplify the information here a little bit. 9.5%. Remember, percent means divide by 100. So it's 9.5 divided by 100, or 0.095. And then I'm going to rewrite root n over n as 1 divided by root n. And then 10.5%, that's 10.5 divided by 100. In other words, it's 0.105. All right, next up, I'm going to take the reciprocal of each of these three parts. So we're going to get 1 divided by 0.095 is less than the square root of n. Now, did you see my mistake there? When we take the reciprocals, because they're both positive numbers, I can't say that it's less than the square root of n anymore. I have to say it's greater than the square root of n. Think about it, right? If 3 is less than 8, 1/3 is bigger than 1/8. So when you take reciprocals of two positive numbers on each side of an inequality, the direction of the inequality is going to shift as well. And then similarly, for the second inequality, we have to turn that into a greater than also. And I'm going to take the reciprocal of the right-hand side, 1 over 0.105. All right. Now, next thing we have to do is we're trying to solve for n, right? So we're going to square all three sides. Now, once again, as long as all three of these numbers are positive, squaring them is not going to change which direction the inequality goes. But we do have to keep that sort of thing in mind, right? So for instance, if you had and one of the numbers being positive and one of them being negative, all the stuff I've said about which direction the inequalities goes, you'd have to throw that out and it kind of analyze it a little bit more deeply. But because we have positive numbers here, if I have one positive number being bigger than a second one, then when I square them, that first positive number squared is still going to be bigger than the second one squared. Okay, so let's square all three sides of this inequality, and we see that 1 over 0.095 squared is greater than n, which is greater than 1 over 0.105 squared. Now, 0.095 squared, 0.105 squared, those are both approximately 0.01. And when we take the reciprocal of each of those, we're going to end up with something around 100, right? So you know, for instance, that n equals 100 is going to work here because if n was 100, that's going to be 1 over 0.1 squared, and that's certainly going to be between these other two values. So we're looking for a number on the order of 100, but I want the greatest one. So my constraint here, I don't actually care that n has to be bigger than 1 over 0.105 squared. What I'm concerned about is the fact that n is less than 1 over 0.095 squared. All right, so let's write that out over here. N is less than 1 over 0.095 squared. Right. And at this point, all you got to do is take out your calculator and figure out what the value is going to be. So I've taken out my calculator, and it says that 1 over 0.095 squared is approximately 110.8 something, right? So n is less than about 110.8, And of course, we are looking for the greatest positive integer. So what's the biggest integer that's less than 110.8? That's going to be n equals 110. And that is how it's done.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.